Good morning, colleague. My name is Joshua Biaruhanga. I'm here with my colleague, Hindom Baraka. We are here to demonstrate the concept of federated learning. Federated learning is a way by which multiple devices or computers work together to train a machine learning model without having to share their raw data. So instead of sending all the data to the central server, each device trains the model on its own local data and then sends only the updated model to the central server. And then the server then combines this update to improve the overall model performance, then sends it back to the individual update. This approach is useful for privacy, efficiency. It helps improve privacy since the data is never shared with the central server. So we are going to train a machine learning model that will predict presence of malaria within the thick blood smear. So allow us to walk you through the process. The first step here, we are loading the libraries that we are going to use within our model. So these are the paths to where the sick blood smears are located. We have a path for affected blood smear, sick blood smears, then a path for unaffected sick blood smears. So the next is the function that will load respective images. So this function here, we are resizing the images, that is to achieve uniformities, to avoid bias within the model, because if some images are larger than the other, then the model will tend to be biased on a particular image. Then this second function, we are loading the images. You realize that our images are in different subfolders. So this function here will walk through each subfolders and retrieves all the images. So after the images have been loaded, we visualize them. So this is how the images looks like. And then after which we have to concatenating, that is merging both the infected and infected sick blood smear. So we have to combine them. Then also we label them, that is the affected one will be given a label of 1 and the uninfected one will be given a label of 0. Then shuffling, this involves mixing, randomly mixing the samples. The aim is to avoid bias within the model. So if these images are not randomly mixed up, the model may tend to be biased, and the biasness will result into overfitting. So that's the major reason for shuffling of the images. Then here we proceeded to train our model. Splitting, I beg your pardon, that is splitting the data into X-train, X-test, and then Y-train and Y-test. Then we also did, we have a sample for validation, that is X-val, X-test, Y-val, then Y-test. Then we shall also split our data for federated learning purpose. Here we are going to simulate the three different regions or three clients. So take an instance, we have a team in Mbarara, we have a team in Gulu, we have a team in Hoima, and then our central server will be, say, in Kampala. So these three different teams are going to train their individual models. Then after they've trained each model, they will send only the updates to the central server that exists at Kampala. Then here we are defining our CNN model. So after we've defined our CNN model, we go ahead and extract the features within our data sets. And from the graphs, from the above graph, you can see that we effectively separated the affected thick blood smears from the unaffected ones. So the one represents the affected blood smear, and then 0 represents unaffected ones. So here we are setting up the three clients, that is Hoima, Gulu, and Mbarara. So these are the three clients that have been set up. For these clients, once we start training the model, the simulated these three clients will run independently. So we shall achieve this using threading. So each after running, they will be able to send updates to the central server. So once they send an update, they get a response. So this is our server which is running. So once it gets an update, it will get an update from each of the different teams, that is Hoima, Gulu, and Mbarara. So that is what we did for this week. We shall continue with the next step of having this model fine-tuned such that we have accurate results. Thank you. That's all from us.